Okay, so I'm going to explain what prime numbers are and how to test if whether a number is prime or not, and also why there are infinite numbers of prime. So what is a prime number? A prime number is, let's say we have x as a number. If x is larger than 1 and is only divisible by 1 and the number itself, x, then this number is a prime number. Okay, so now I'm going to introduce you to how to test if a number is a prime number or not. Okay, so primality test. One of the known tests to test if a number is prime or not is called the Fermat test. So basically, the Fermat test is a process where if we have a, which is the number between 1 and p, which is our number, and a times squared by p, and if this result is the multitude of p, then this number p is a prime number. So let's have an example. Let's say 7. Now 7 is a number that we all know that is a prime number immediately, because we know for a fact that this is a prime number, and since it's a very small number, but numbers like 7043, like these numbers are hard to prove, and this Fermat test is one way to prove if a prime number is, if this is a prime number or not. So let's say equals 0, and this is the multitude of 7, since 0 times 7 is 0, and this is 126, which is 18 times 7. So like this, continuing on until we reach this. And if this number is, and if all of these numbers are the multitude of 7, then 7 is going to be a prime number. Okay, so the next thing I'm going to talk about is the proof whether or not there is infinite number of primes. So prime numbers are numbers that are only divisible by 1 and itself. And composite number are numbers that are divisible, that can be written with prime numbers. So let's say 6 can be written as 2 times 3, like this. And let's assume that there are finitely many primes, and let's say Pn is the biggest number that we have, the biggest prime number that we have, and let's say that the multitude of all of these numbers plus 1 equals p. So p would be bigger than all of these primes, let's say 2, 3, 5, 7, 11, so on. P would be bigger than the multitude of all of these primes plus 1. So P is a number that can be written out with primes, which is a composite number. P is composite. And now let's divide P with these prime numbers to see whether or not that this is a composite or a prime number. P1, P1, P2. So this would result in P2, P3, blah blah blah, Pn plus 1. However, this is not this does not give us an integer, so therefore P1 is not the factor for the number P. And this applies to P2 and P3 and P4 and so on and so forth as well. This means that all of these prime numbers are not the factors of P, which means that P can only be divisible by 1 and itself. Now this is important because this means that P is a prime number. But look, at first we said that P is a composite number because it is the multitude of all of these finite prime numbers, and there are no other prime numbers. However, if we see here, we have just proven that P is actually a prime number, so there is a contradiction. Therefore, that the claim that there can only be a finite number of prime numbers is false, and therefore there are infinitely many primes.